Good morning to everyone. My name is Marina Siljic, and I'm Senior Research Associate at the Faculty of Medicine, University of Belgrade in Serbia. At the beginning of my presentation, I would like to thank organizers for this great opportunity to present the results of our research. It's a really great pleasure and honor to be here on this stage as a presenter. And the title of my today's presentation is Transmission Characteristic and Evolutionary Dynamic of HIV Epidemic in Serbia. So now a little bit of phylogeny and bioinformatics, not instead, but in addition to epidemiology and clinic. The duration of HIV epidemic in Serbia is similar to the one in Western Europe, with the first cases registered in 1985. According to the latest 2024 data from the Institute of Public Health of Serbia, a total of over 4,900 cases of HIV infection have been registered in Serbia, and since 2000, an incidence rate was 1.2 per 100,000 inhabitants. Since 2015, an increase in incidence rate has been noticed until 2020, when a reduction of registered new HIV cases had been observed, probably due to the COVID-19 pandemics and the general overload of the healthcare system, and the incidence rate fell to 1.2 per 100,000 inhabitants. In 2024, 147 new HIV diagnoses was reported, which is 20% higher than previous 2023, but 20% less than in 2019. HIV epidemic in Serbia started among people who injected drugs, and this transmission route was the most prevailing one over the following years until mid-1990s, when heterosexual transmission route became more prevalent. And in the last decades, another shift in a dominant transmission route has been observed, leading to the current situation when men who have sex with men are driving force of HIV epidemic in our country. HIV epidemic in Serbia shows something that we call compartmentalization, as described in the rest of Europe and globally, with a lot of sub-epidemics within national epidemic. And indeed, since 1985, HIV epidemic has evolved in terms of subtype distribution, transmission routes, and the characteristic of a transmission clusters. Our research team, led by Professor Maja Stanović from Belgrade, is actually, I can say, well known for applying advanced and sophisticated phylogenetic analysis in a research of viral epidemic in Serbia and regionally as well. And what is actually viral phylogenetic analysis, and why is it important? Viral phylogenetic analysis is critical for assessing both HIV epidemiological and evolutionary dynamic in population, and it is actually a very important tool to both design and evaluate HIV control strategies. Furthermore, the identification of transmission clusters in a phylogeny tree can support epidemiologically linked transmission events, can identify putative transmission chains, and reveal the mixing between key risk groups and geographic subpopulation. And in addition, if we integrate detailed demographic, epidemiological, and clinical data into this analysis, we will get phylogenetic analysis that is indispensable part of HIV prevention strategy and may reveal the underlying factors that contribute to the growth of subepidemic, delineate the ongoing and the future trends that is vital to establishing evidence-based decision. What were the aims of our research? First aim was to analyze the prevalence of HIV subtypes circulating in Serbia. The second aim was to identify and characterize HIV transmission clusters, and further on to analyze evolutionary dynamic of each identified transmission clusters. And lastly, our aim was to correlate socio-demographic and the clinical characteristic of a patient's to transmission clustering patterns. Within this study, we include 740 healthcare clients living with HIV, linked to HIV/AIDS unit of the University Hospital for Infectious and Tropical Disease in Belgrade, sampled from 2002 to 2024, both therapy naive and therapy experienced. And in order to identify HIV subtypes, we used different HIV subtyping tools such as REGA and the COMET test coupled with phylogenetic analysis, and in order to construct phylogenetic tree, we performed maximum likelihood algorithm in a different software such as MEGA and IQ3 under the general time reversible nucleotide substitution model and a different statistical support to tree branches such as bootstrap support and Bayesian posterior probability. One of the major challenges in our research was adoption of appropriate criteria for transmission cluster identification. And indeed, criteria for transmission cluster identification vary widely in a current literature, still without any consensus. In our research, we included genetic distance among the sequences within transmission cluster, up to 4.5%, so that was our threshold. Then bootstrap support for a phylogenetic clade, that should be higher than 90%, and a Bayesian posterior probability that should be higher than 0.9. In addition to genetic distance and statistical support to tree branches, we additionally included foreign sequences based on NCBI BLAST analysis. What we actually did here, for each sequence belong to a phylogenetic clade, we additionally included 5 to 10 genetically most similar sequences based on NCBI BLAST analysis, downloaded them, and included them in a tree reconstruction. In a posterior analysis, those clades, without any intermixing of a foreign sequencing to a local one, could be considered as a true local transmission cluster. Phylogenetic clades found with the intermixing of foreign sequences, but sampled in the Balkan region, in our region, could be considered as a cross-border rather than a local. And last, phylogenetic clades found with intermixing of foreign sequences to a local one, but sampled outside of the Balkan region, were dismissed from the further phylogenetic investigation. Our next challenge in this research was how to estimate effective reproductive number for each identified transmission cluster. Actually, what is effective reproductive number and why is it important? Effective reproductive number is a key indicator of the growth of an epidemic. It became really popular, well-known, and well-used during the COVID-19 pandemic. Since the start of the SARS-CoV-2 pandemic, many methods and online dashboards simply sprang up in order to estimate this parameter through time. How can you actually interpret this parameter? Very simple. If this value RE is higher than 1, that means that this epidemic will have further spread and further grow. If this parameter is lower than 1, then eventually epidemic will die out. The higher the value of RE, the faster an epidemic will progress. In our research, we used software called BEAST2 software, and our software to estimate this indicator through time. And lastly, we performed advanced statistical analysis called latent class analysis, also in our software. This analysis will show to us a correlation between sociodemographic and the clinical characteristic of a patient with transmission clustering patterns. This analysis will actually reveal to us, let's say, hidden subgroups or latent classes characterized by a complex association of investigated characteristics. And these are our results. All subtyping tool together with the phylogenetic analysis gave congruent results in terms of subtype distribution. Of 740 successfully generated HIV poll sequences, subtype B was found with the highest prevalence, following by the subtype A, identified as the most prevalent non-B subtypes in our research, found in 70 poll sequences. Subtype C was found in the 28, and subtype G only in 10. Regarding the identification of transmission clusters, considerable proportion of HIV Serbian poll sequences were found grouped within 27 phylogenetically well-defined transmission clusters. In addition, we found one very large expanded transmission cluster composed of 85 HIV pole sequences from Serbia. So all of these transmission clusters were identified based on genetic distance and statistical support, bootstrap support and Bayesian posterior probability. In addition, when we include foreign sequences based on NCBI blast analysis, we found 7 out of 27 transmission clusters intermixed with the foreign sequences sampled in the Balkan region, predominantly from Slovenia, Croatia, and Montenegro, and those transmission clusters could be considered as a cross-border and not a local one. Regarding the estimation of the effective reproductive number, 10 out of 27 transmission clusters were found with a value higher than 1, suggesting the high potential for the further epidemic spread. On this slide, I presented only one figure based on estimation of the effective reproductive number for the larger transmission cluster. And as you can see, starting from 2015, it's increase of RE through time, and during the last, let's say, 5 years, the value of RE is around 1.3, which suggests strong potential for the further epidemic spread and growth of this local transmission cluster. Lastly, this is the results of latent class analysis, and latent class analysis revealed the presence of 4 subgroups. I will emphasize just one, that is most interesting one, and that is the first one. On this figure, darker color represents higher proportion. So, first class encompassed the patients whose viral sequences was grouped within transmission clusters. Those patients are predominantly male, younger and the middle age, MSM, living in a Belgrade with a higher education, presented in an early stage of infection and with other sexual transmitted illness and Hep B as well. So in conclusion, HIV epidemic in Serbia is still like the beginning of epidemic characterized by the predominance of subtype B. However, with the growing prevalence of subtype A, especially from the 2022. We found considerable proportion of sequences, HIV sequences grouped within a transmission cluster, so HIV epidemic in Serbia spread among local transmission clusters associated with MSM, Hep B, and other sexual transmitted illness, and definitely other important question will be the further investigation of the growing subtype A in our country. And at the end, this is my own phylogenetic tree of acknowledgement. In the root of knowledge is my professor and my supervisor, and all the other colleagues who indispensably help with this research. Thank you very much for your attention.